That's the best part of all. This guy just does it because he's so damn brilliant. And you know, somebody else who's not as brilliant, but he promises to be up here for no less than 8 minutes. And I think he was really inspired by the end of this last cartoon and the Men from Mars bit and all that. This guy likes to get up, and I know one thing he's going to want to talk to you about tonight, folks, is something none of us can see, and that's the big eclipse going on in Kansas. We got this guy, he says a lot of stuff about space, yet he lays a lot of pipe during the day. I'm sorry, tile during the day. Somehow being down on his knees makes him feel like he's out there deep in outer space. It means I'm really talking about one person only, and really he does promise to be here once again, no less than 8 minutes. Pete Goldie, ladies and gentlemen, Pete Goldie. Hi, Pete. Oh, hi, John. 7 minutes, ladies and gentlemen, 7 minutes.
You said 8.
You can't prove that.
You're not. Doug's got a camera.
Okay, go.
Ready?
No, I'm setting up.
Oh,
Of course, these are not Earth minutes. They are lengthy sidereal minutes. Keep that in mind.
Hal, if I move these dinosaurs, you're not going to get all, you know...
Don't touch the dinosaurs, Pete.
ADHD on me, are you?
Well, I should be looming over the little miniature kitschy Christmas village, but you're up.
What if this hadrosaur falls over?
Oh my God!
That
what are you
used
doing?
to happen in the Mesozoic. Do with them what you will.
Look,
I
dead
think he's being
hadrosaur.
very rude and disrespectful.
So how are they bothering you? I don't know.
It's
I
Pete.
can't
Pete's
see
bothering me.
the member of the audience over there.
Well, maybe they can't see you. Anyway,
Okay, wait a second. I'll just block out Michael Pepe with it. There.
It's a dash
Now
of
it's serving a
Hamilton.
purpose.
Oh.
It's okay.
and now
Oh my God, he's extinct. Sorry.
The Space and Science Report from Pete Goldie, everybody. Don't encourage him. Please don't encourage him.
We're his fan club.
5
Oh
minutes.
my God. How much does he pay you?
I'm here delivering a space science report
At
for
last.
May 24th, 2013.
Space.
There. And in the first picture you see here is a lunar eclipse. What is so interesting about a lunar eclipse on this night, you may wonder? Why is tonight unlike any other... How does that go?
Why is this night different from all other nights?
Why is this night different from all other nights?
Because the moon is practically full.
Oh, the moon is full. It's a full moon tonight.
I thought it was the 25th.
I'd like everyone to know that you only have a lunar eclipse on a full moon. Why is that?
You can't cover it all if it's not all there.
If Michael Pepe calls out one more time, it's detention.
You asked me.
Bang the hammer.
I had to put my hand.
Okay. It's a parenthetical rhetorical question. Is that the right way to say it?
It is for you.
Thank you. This is an annular eclipse. You notice you have a little ring of fire around it because,
K-Rock?
you know. This is in Monument Valley. Everyone been there? These are the mittens. The left mitten, the right mitten.
This show happened recently.
There. Look at this. This is also called. This is called a lunar caterpillar, unlike the human caterpillar.
Looks like a ding-dong.
And what they did is they actually did the moon moves through the sky. So if you were to take an image of the moon with a camera as it moves, you would see it move through the sky here. And you got a lunar caterpillar. And you had a partial eclipse happen during this. And this happened last month. In fact, it happened on April 25th, not long ago. So how can there be a lunar eclipse happening again? There was one 2 months ago, a small one, a ring of fire. Then there was a
K-Rock.
partial one here on April 25th. When is the next lunar eclipse? Does anyone know?
Right now.
Right now. It's happening right now.
Whoa!
There you go.
And you're here?
Not only that, I
I
am
know.
here. According to our top scientists and lunatics, they say that the eclipse tonight, it's the most barest, lamest, smallest sliver of distraction.
Don't hurt its self-esteem, man.
Just a full moon tonight. No one would notice the difference. Since you're all so hot on the moon, I want to show you something that might be slightly more interesting. I think we have a video. Is that right?
8 minutes.
Well, the video's number 4.
Damn right. You know what? Aren't you happy Aren't you happy that we actually have eclipses in our solar system? Have you tried other solar systems lately? Do you know if you went to another solar system where the sun was larger, you would not see, it would be like tonight's lunar eclipse, you would not notice it. For example, this star here, Canis Major, also called Dog Star, it happens to be very large. You see, this is the size of our sun compared to this star. Something is wrong, though, in this. According to other astrophysicists and cosmologists, not to be confused with cosmeticians,
What did he say?
a sun cannot be more
It doesn't.
than about 10 solar masses. Yet here is a star they calculate to be over 1,000 solar masses, maybe more. It's too big. It
Well,
can't
who
be this
made
big.
that rule to begin with?
People with slide rules,
Maybe-
supercomputers.
Maybe
Helmholtz.
it's just big boned.
It gets so big it collapses in on itself and becomes a black hole.
It was Helmholtz.
Boom.
However, this one, as you can see, is clearly larger. And yeah, now if you saw that episode of Star Trek,
Oh yeah.
you know the one where
No.
there was the one where it was these big. The Enterprise got near this ball and it got bigger and bigger and bigger and bigger. It was like the Enterprise was this big compared to this giant ship. What is the name of that episode?
Carbonite maneuver.
There you go. The Carbonite maneuver.
Carbonite maneuver.
Exactly. For 500.
That's right.
And just like the Ask Dr. Hal show, it turns out that it was just a puppet scaring everyone.
Oh.
Yeah. But anyway, he lived in a huge ship like this, but actually he lived in a tiny little shuttlecraft that just puttered around. Now let's go back to the moon, where we actually have eclipses and other things happen on the moon. We're gonna watch a video here because there's something exciting. They have a new program going on the moon, and it's science. Yes, science.
Not Nazis.
What they have done is they have some observers watching the moon all the time. And you know what they're seeing on the moon?
Nazis.
Nazis. Oh damn.
Besides the Nazis, they're in the North Pole. They are actually seeing things hit the moon, and they're meteors, and they hit the moon and become lunar meteorites.
Whoa.
There they go, bam, bam, flash, flash, boom! Terrible, terrible things happen.
Awesome.
Well, who cares? They've been looking since about 2005 with all these cameras. Now, in Mare Imbrium, the largest, brightest one just happened to have hit. It is
Wow.
10 or 20, or who knows, 100, some number larger than any other flash they've seen. You want to see that flash? Anyone want to see it? There it is. Yay! Anyone want to see it again in slow-mo?
No, that's okay.
Yeah.
Okay, I promise I'll show it in slow-mo. There you go! That's it. And it's right next to that giant triangle. It makes it easy
What
to
is
see.
that doing
It was
there?
painted on the moon. It's
I
a
didn't
target.
see it because of the green thing.
This guy really wants to see it again in slow-mo.
One more.
There we go. Whoa! Boom! Guess how big that was? It was
How
actually-
big?
Oh, it was a rock. It was maybe, I don't know, 50 feet across. Oh, I think it was 40 kilotons.
Whoa.
Maybe it was- Someone, oh yeah, and it was like 5 tons of
4
TNT.
tons.
Big bag of
But they think that the hole it made, oh, and when they saw that, there was a whole bunch of other
dust.
meteoric activity happening here on Earth. Earth.
That's a robot.
Yes. You see these, now here we're looking at Earth shots. These are wide-angle cameras they have at night, which are just for picking up shooting stars. And they saw a whole bunch of shooting stars, like, wow, we didn't expect all these shooting stars. And suddenly, bam, this thing hits the moon. Coincidence?
Yes.
No.
Yes.
No.
Yes.
No.
Pete?
No, not a coincidence.
Pete?
It's all happening. What?
Do you masturbate to this stuff?
Do I seem excited?
He's a happily
you know.
Lifting ever so slightly.
Kinda.
I
Okay.
am.
His mind.
You know, it doesn't matter because.
I'll go faster and faster and faster.
Okay.
Oh, okay,
No,
Pete.
no, slow
So
down.
that you are
You want me to slow down? I'll slow down by giving away something. Here's a sticker. Anyone want a
I do,
NASA
I do.
sticker tonight?
I do.
Who deserves it? This is for the, yeah, it's a NASA sticker. It has gum on the back. You put it on something and it stays there. Who wants it?
I'll put it on the
Okay, come and get it.
Gotta ask a question.
Not Michael
then.
Pepe,
Not Michael
anyone
Pepe.
else?
Oh, yeah.
There.
Anna wants it.
There we go. Okay.
I deserve it.
Rhiannon? There you go. Hey, wait, Rhiannon, you can have a better one. Okay. This one is from the Applied Physics Laboratory at Johns Hopkins University, one of the best research institutions when it comes to planetary science anywhere.
Wow, Rhiannon, look at that.
And now,
That's
the next
nice.
sticker here goes to Irma Hemp. She can come up and get it. Come and get this NASA stick. Come on up. It's for you. Come right to the stick. Yes, you. You walk in here. Not knowing what's going on. And now you have to go on stage.
And then there's the masturbation comment.
We'll have to Where's Craig?
Don't worry, I got a million of
Your
them.
genuine analysis there. There you go. Enjoy. You put it on your computer. Yes. You put it on Okay. By the way, this video is still playing. It's an 8-minute video. I don't know. So
8 minutes?
I didn't mean to drag it out so long, but this is actually. I gave away the stickers between the part where I had nothing to say.
Oh.
Oh, it's over. We're done with
the
that.
quiz?
We're done with that.
Yeah, we're done.
Okay.
Don't see that anymore. Now,
I agree.
ladies and gentlemen,
What?
I want to talk to you tonight about something important that's in the outer solar system. I mean, not really the outer solar system, but the one I'm going to talk about is the outer solar system.
The Scott Kuiper belt.
Tonight I'm going to talk about Trojans.
Oh.
What Trojans are,
Where are Kuiper belts?
Trojans, masturbation. Keep going.
what Trojans are moons of planets. They're actually not moons, they're actually co-orbiting bodies of major planets. Now, what I want to talk about is they have recently discovered a new Trojan of Neptune. Now this is really rather rare. Jupiter, way in here, you see Jupiter in the inner solar system here, has over 5,000 Trojan moons found. And I say moons, but they're actually co-orbiting. They actually orbit within the same orbit as the planet, but usually 60 degrees in front of the orbit or 60 degrees in back of the orbit, not precisely on average. And they move around there in something of an orbit called a libration point. Anyway, I want to show you this because this is showing the outer the giant ice planets of the outer solar system: Jupiter, Saturn, Uranus, Neptune, and then this the asteroid Pluto.
Asteroid, that's a planet, goddammit.
Planetoid.
Asteroid
Planet.
0184.
Planet.
Mickey Mouse is
The planetoid formerly known as Pluto.
It's
Planet.
clearly not a planet. Look at this, he's flying in orbit, so far away. Anyway, in the next image, what I'm going to do is start to tell you about the Trojans they have found. Now, what they did is they have, because we are sending a mission out to Pluto right now that's on its way, and it's called the New Horizons mission. In front of the orbit, they are looking in back of the orbit. That spacecraft is on its way to Pluto, and it's pretty much going directly toward Pluto. If we were in the inner solar system, that would be. Anyway, I want to show you there because if you're looking at your pretty much line of sight, if you're looking at Pluto, right along there is New Horizons spacecraft on its Neptune, and then it will take another 2 years. I'll give you those numbers a little bit later in this show.
A little bit. How much is freaking later?
Another minute there. Now the reason that they're looking looking in the direction of this spacecraft is once they go to Pluto, they actually think, hey, why don't we swing around and go to one of those other neat bodies in the Kuiper belt? Another icy body out there. We're already going to set the spacecraft out there. Not that they're going to do a lot of change of direction. Now, what they did is they have, because we are sending a mission out to Pluto right now that's on its way, and it's called the New Horizons mission. They are looking, and that spacecraft is on its way to Pluto, and it's pretty much going directly toward Pluto. If we were in the inner solar system, they think that the amount of mass there, and if you're looking at alone, pretty much in line of sight, if you're looking at Pluto, right along there is New Horizons. Another minute. So they're doing a lot of looking, and serendipitously, they found another Trojan. Now, as I say, in the inner solar system here, they have found over 5,000 for Jupiter, and they think that there are perhaps 1 million. They think that the amount of mass in the Trojans alone for Jupiter are equivalent to all the mass of all the asteroids in the asteroid belt. Yes, which is a significant amount of mass.
Pete,
Yes?
do you sometimes wish that you were a Trojan?
Moving along here. Now again, the L5, if you look at this is 60 degrees behind the orbit
That's a yes.
of Neptune, is the L5 point. If you went 60 degrees in front of the orbit, you hit the L4 point, and that's the Lagrange point for, or actually Lagrange point if you're a mathematician, the famous French mathematician Lagrange.
I'm not.
There.
I don't care.
There.
How long will it take to get there?
It will take another 2 years. I'll give you those numbers a little bit later in this show.
Little bit. How much freaking later?
Another minute there. Now the reason that they are looking in the direction of this spacecraft is Once they go to Pluto, they're actually thinking, hey, why don't we swing around and go to one of those other neat bodies in the Kuiper Belt, another icy body out there. We already sent the spacecraft out there. So they're doing a lot of looking, and serendipitously, they have found over 5,000 for Jupiter. And they think that there are perhaps 1 million. They think that the amount of mass in the Trojans alone for Jupiter are equivalent to all the mass of all the asteroids. Next,
Yes, an illustration of a Trojan.
an illustration of a Trojan. I'd like to show you.
USC.
Oh, good one.
Thank you.
There we go. Thank you for not showing the other Trojan everyone has
I
on
don't know
their
what else
mind.
you're talking. I don't know what you're talking about. I know what you're talking about.
Now, if you were to stare at the toward Pluto and you wanted to find some new object out
Oh, is
there,
it like one of those images you stare at, something pops out at you?
yeah, this
That
is it.
never worked in the 1980s.
If you have a good, what you need to find small dim bodies that far out is you need a very good telescope that has a very wide angle of view. There's only about 6 of them in the world that could do this sort of work. And this is what they would see if they're staring out there in the L5 region around Neptune. They're staring out there and they're going, hey, you know, we want to find, these are all stars pretty much. Some of them are asteroids, some of the others. But what they're looking for is actually not even visible on the screen. It's much smaller than the end of the dot at the end of that arrow. Now, how would you find it amongst all of this mass, you ask?
Motion.
I will show you with the next animation. What they do is they take a picture, and then they remove all the known stars.
What?
Yeah, just watch. I will
But you can do that with the new iPhone, right?
chemically remove all of those. You just wait. It will go away. Because this is
They're towing him away.
Oh, there they go. And they go away. And suddenly, oh yes, it's got to be that one there. That's why they're doing it. The next one is going to be much more interesting because now we're actually going to see this next Trojan. We're going to see the real thing taken by a Earth telescope. And if you look closely, there it is. You see? That's right. Now they found about, that's like the 6th Trojan found around in a co-orbit of Neptune. Like I say, there are 5,000 around Jupiter. Guess how many there are around Earth?
1 million.
One. They have found 1 Trojan around Earth.
Look on Cap Street.
Guess how many they have found around Mars?
1 million.
300.
300 million.
300 million and 10.
Nazis.
1.
1 million.
Now guess how many they think are around Neptune. If there are 5,000 around Jupiter and they found 6 so far around Neptune. They estimate there's 1 million. Thank you, that was the right answer. It was 1 million. They estimate 1 million, they just can't find them, but they think they're there.
How many around Uranus?
Depends on the
Wait, I
time
have
of
that. I have that number. They have them around Uranus. It's in my notes right here on this 3rd
Just get a
page.
shot through that shit right up.
Now, this will actually show you the interesting orbital pattern that a Trojan has when it's going around there. Yes, now what we're going to do is we're going to speed up. This is the Trojan here. These are the inner planets zipping around. This will be Earth. If you were just watching, well, say you just made everything stationary and saw it going around. But that looks like confusing. How could that be orbiting in that strange little curly
Do you
cube
see
around
that
it?
when I go like that? Do you see that when I go?
Now what they're doing is they're speeding up time, and they actually ran a simulation of this latest Trojan to see, is it in a stable orbit or is it not? And they ran it out 1 billion years. It is a very stable orbit. It's going to be there for 1 billion years. Unless something hits it. It looks like a heart. But we're going to watch this a little longer because this might be easier to visualize once they tilt the plane. We're looking from the top down at the orbit of it. As we tilt it, that's how it orbits. That's how it does it. You actually don't just float around in space at the L5 point. You orbit it there in a very unusual way. And if you run the simulation forward 1 billion years, that one is stable and it's going to be there for quite a while.
You will love Pete Goldie.
Just make science.
That's great.
I like boobs.
And the name of that one, by the way, they gave it the name.
Orbiting
it's,
moves.
2011 HM102.
He can't see.
You didn't explain what a Lagrange point was.
Yes.
however.
Yeah.
A Lagrange point is where
Don't slow him down.
it's basically where gravity is canceled out. Bingo.
And
All right, yeah,
L5, for example, aren't you referring to the Lagrange point there?
That's right, the L5 point. There are exactly, how many Lagrange points are there around an orbiting body, pal?
Million.
I just thought there was one.
Oh, no. There's one that is sunward. There's one that is on the other side of the sun, if you were in conjunction. That's 1 and 2, L1, L2, L3, L4, and L5. There are 5 Lagrange points around orbiting bodies. And there's basically where the gravity's
Sorry,
cancel out.
5 to a customer.
Yes, and you can throw a spacecraft up there in a slow little orbit, and it basically will stay there forever. We've sent numerous spacecraft now to the various Lagrange points around Earth. Remember Earth? And they do various good things. Like the James Webb Telescope is going to go to a Lagrange point.
Perhaps you'd like to tell us just for a moment about your thoughts on NASA's newest plan to lasso an asteroid.
Oh yeah, it's good preparation for our next intergalactic war. Yeah. Without a doubt. There's a reason that they're doing it. I'm sure it's nefarious. Yes, they are going to literally go around there and put it in a baggie and drag it to Earth. Or drag it to an orbit near Earth. I guess they're going to make it orbit one of the L points, right?
Sure.
You didn't put it in an envelope, Pete.
Yeah. Anyway, I'm sure that it's going to be a great project, and that's not going to be a subject we're going to go in further with this meeting.
Bring me down, bring me down, bring me down.
Another interesting thing about it, again, this is the spacecraft called New Horizons heading toward Pluto. It is now the closest object to that Trojan. And by the end of this year, it's going to be close enough that this wonderful spacecraft, New Horizons, heading toward Pluto, will take a picture of that Trojan from the vantage point of 1.2 astronomical units away. And you know an astronomical unit is 93 million miles, so it's going to be about 110 million miles away, and there'll be nothing else near it at all. How long until this spacecraft reaches the Pluto system?
I did that.
How long?
That's right. Well, it's been flying for 2,682 days, 6 hours, 56 minutes, 23 seconds.
Only you
And
know
it
that,
will
Pete.
be there. It will be the closest approach to Pluto in 780 days, 10 hours, 2 minutes, and 37 seconds from now. And then, another reason that they're
40.
taking so much care and looking at the Pluto system, it's got to thread the needle. Yes, they are shooting it inside the orbits of 5 known moons of Pluto.
That's what they're for.
Charon, Nix, Hydra, and of course we have P4 and P5. Unnamed
Give it
yet.
up, people.
No,
My
they're
bitch.
actually shooting it inside the innermost orbit that they know of any moon around Pluto. They're literally threading the needle. And they just had a very important conference where all the top scientists with their big, bulging, throbbing brains had to get together and say, since we keep finding new moons of Pluto, are we going to hit something when we get there?
Sure.
And they said, after doing all their little math things, they said, you know what? Sending it right here on the inside of this major moon and this whole area here is the safest place we can go. Because Pluto and Charon, they both decided that they have enough gravity that if there's small little dust-shaped things that they might hit and damage the thing, they have enough gravity to actually clear it out every few months. So, the safest place you can send it is where they already targeted. So they're not going to change the direction at all at this point. When they get closer and they start turning the cameras on and take a few peeks, if they see something there that makes them worry, well, they might try and move it around a little bit. They only got a little bit of leeway at that point. How much money are we spending on all the NASA missions? Now, if anyone can figure out what this chart says, it's absolutely nuts. Look, the Mars spending is going down, but they say it's going up. This is going down, up, everything's going up. I can't figure out this chart at all. Go to the next chart. It's crazy. Now, here's the problem. Planetary science, bam, wrong. I mean, look at that. Every single planetary mission that we send on seems to pay back more than anybody expects.
What about those juice?
Juice?
Juice, they got a problem.
Juice. Yes, that's the Jim Webb Space Telescope.
Look,
And-
juice.
Well, get Jim Webb to pay
Yes,
for it.
and Jim Webb ain't paying for nothing. He's dead. Yeah, that thing is taking way more money than they calculated. And what they should do is actually raise taxes, right? Yay! Then they'll fix it. And then this line will, instead of going down, will go up, 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 up. But anyway, how do we plan for the future? With this depressing waste, you're right, college. Next image. I show you that my daughter is still planning. I like to point out, although you can't see her, she just got her diploma. Yay!
Monkey.
This is not her diploma, but she got best reader. She is ready.
Yes, monkey.
Thank you very much.
Our own small gym body, Pete Goldie, ladies and
Pete
gentlemen.
Goldie, ladies and gentlemen.
Oh, that's lovely.
Poor little dwarf
Pluto's a
planet.
fucking planet, man.
Yeah.
I don't care what anybody says, goddammit.
Fuck Pluto.
Up yours, champ!